Hello viewers, in today's lecture we are going to solve some very important uh, problems in integration. Now viewers, in this lecture I am going to take up some important problems which seems very difficult, but actually these problems are not difficult, right? The only thing which we require is a close inspection of the integrand which is given here. So let us solve the first problem. So here we have to integrate cos cube x e raised to log sin x dx, and let us call this integral as I. Now here the integrand or this function, it seems very difficult, but actually it is not. Why? Because if we closely look at this function, we see that e raised to log sin x can be written as sin x. Why? Because we know that e raised to log of f of x is equal to f of x. So this integral now becomes cos cube x, and for e raised to log sin x we have simply sin x, right? Now here we can now put t is equal to cos x, and now we will apply here the method of substitution, and if we put t equal to cos x, we have dt is equal to minus sin x dx, right? So therefore this integral now becomes integral for cos cube x we have t cube, and for sin x dx we have minus dt, right? Now this is minus t cube dt, and this can be written as minus t raised to 4 by 4 plus c, right? And if we again resubstitute the value of cos, so here the value of t is cos x, so we have minus cos raised to 4 cos x raised to 4 divided by 4 plus c. So viewers, the value of this integral is cos x raised to 4 divided by 4, and here we have minus sign plus c. Now viewers, let us take this problem. Here we have to integrate this function which is e raised to 3 log x times x raised to 4 plus 1 raised to power minus 1. Now let us call this integral as I. Now again, as I have said earlier, this function seems quite difficult at the first glance, right? So but if we take a close look at this function, we see that e raised to 3 log x can be written as e raised to log x cube, right? Because by the property of log, m raised to n is n log m, and as we have just seen in the previous example that e raised to log of f of x is equal to f of x, so e raised to log x cube is equal to x cube. So therefore this integral becomes for e raised to 3 log x we have x cube, and here we have x raised to 4 plus 1 raised to minus 1 dx, and this can be written as 3 divided by x raised to 4 plus 1 dx. And now if we multiply the numerator by 4 and divide it by 4, we see that the derivative of this function, it is present in the numerator. So this is log of x raised to 4 plus 1, because the integral of 4x cubed divided by x raised to 4 plus 1 is log of mod of x raised to 4 plus 1 and plus c. So this is the integral of this function, right? And here we have used the fact that integral of f prime of x divided by f of x dx is log of f of x. Clear? Now let us take this problem. Here we have to integrate f prime of ax plus b times f of ax plus b raised to n dx. So let us call this integral as I. And viewers, again here we see that this function, this whole function, it seems very difficult, but actually it is not. Why? If we take a close look at this function, we see that this dash or prime sign indicates that it is the derivative of this function, right? It means f prime of ax plus b is actually d by dx of f of ax plus b, right? Okay, now here if we substitute t is equal to ax plus b, then dt is equal to a dx, right? Because the derivative of b is 0, so therefore this integral I becomes f prime of t, and here we have f of t raised to n, and for dx we have dt divided by a, right? Okay, now this can be written as 1 over a. This is integral f prime of t, and we have ft of raised to n, and here we have dt, right? Now if we take ft as say y, if y is f of t, then dy over dt can be written as f dash t, right? So dy can be written as f prime of t dt, and for here for f dash t dt we can write dy, and for ft we can write y. So we have y raised to n, and here we have dy, right? Because f prime of t dt is equal to dy. Now the integral of this function is very easy. This is 1 upon a times y raised to n plus 1 divided by n plus 1 plus c. Now this is a times n plus 1. For y we can write f of t raised to n plus 1 plus c, and for t we can write this value. So this is 1 over a n plus 1 and f of ax plus b raised to n plus 1, right, plus c. So this is the required integral. Now viewers, let us take this problem. This is also a very important problem, and here the function is e raised to 5 log x minus e raised to 4 log x divided by e raised to 3 log x minus e raised to 2 log x, and let us call this integral as I. And here again we see that this function, it looks very difficult, right? But it is actually not a difficult function if we take a close look at it, and we can easily simplify it, right? So here again we are going to use this result, that is e raised to log of some function f is equal to f of x, right? Or in other words, we can say that e raised to log say a is equal to a. So here for this integral we can write e raised to log x raised to 5. By the property of log, this 5 comes to the power of x. Similarly, for other terms, we have log x raised to 4 here, divided by e raised to log x raised to 3 minus e raised to log, and here we have x square, and it is dx. Now utilizing this result, e raised to log a, so here we have x raised to 5 minus x raised to 4 divided by x cube minus x square, and here we have dx. Now if we take x square common from the numerator, we have x cube minus x square, and here we have x cube minus x square dx, right? Now this factor and this factor get cancelled, so we are left with integral of x square dx. So this is x cube by 3 plus c. So viewers, the integral of this function is x cube over 3 plus c. Now let us take this problem. Here we have to integrate 1 over e raised to x plus e raised to minus x. So let us first call this integral as I. Now again, as I have said earlier, that these integrals which we are solving in this lecture are very easy. The only thing we require is to take a close look and to identify the function, or to apply the known results, right? So here the integral is given as 1 over e raised to x plus e raised to minus x. So what we can do here, if we write this integral as dx over e raised to this can be written as e raised to x plus 1 over e raised to x, right? So here we have e raised to x plus this is e raised to minus x, so we can write it 1 over e raised to x. Now this can be written as e raised to x dx divided by, here if we take the LCM, then we have e raised to 2x plus 1, and this can be written as e raised to x dx, and this can be written as e raised to x square plus 1. Now if we put say t is equal to e raised to x, we have dt over dx is equal to e raised to x, so dt can be written as e raised to x dx, right? Now this integral now becomes for e raised to x dx, we can write dt, and for e raised to x we can write t, so this is t square plus 1, and we know that 1 over 1 plus t square is tan inverse of t plus c, right? And for t we can write this value, that is e raised to x plus c. So this is the required integral of this function. Now let us take this problem. Here we have to integrate cos 2x divided by sine x plus cos x whole square. Now viewers, again this function seems very difficult, but it is not that difficult, right? Why? Because we can simplify this expression first before integrating, and what we will do, we will write it as cos 2x divided by sin x plus cos x whole square. So this can be written as sin square x plus cos square x plus 2 sin x cos x, right? Okay, now we have cos 2x divided by 1 plus sin square x plus cos square x is 1. So this is 1 plus 2 sin x cos x. 2 sin x cos x can be written as sin 2x here, and here we have dx, right? Now if we substitute t is equal to 1 plus sin 2x, t equal to 1 plus sin 2x, then we have dt over dx as 2 cos 2x, right? Because the derivative of 1 is 0 and the derivative of sin 2x is 2 cos 2x, and dt over 2 is equal to cos 2x dx, right? Now for this cos 2x dx, here we can write dt by 2, and 1 plus sin 2x is t. So this is half integral of 1 over t, and this is half log t plus c, right? Because the integral of 1 over t is the log of t, and here we have half log t is 1 plus sin 2x, right, plus c. So this is the required integral of this function. But here we can also express this expression in the form, if we write it as half log 1 plus sin 2x. 1 plus sin 2x is actually equal to sin x plus cos x whole square, and if we take 2 in front of log, so we have 2 log sin x plus cos x plus c. So 2 and 2 get cancelled, so we have the final answer as log of sin x plus cos x plus c, right? So here we have used the result log m raised to n is n log m, right? Now let us take this problem. Here we have to integrate cos x divided by square root of 4 minus sin square x, and again this is an easy problem. So what we will do, we will substitute t is equal to sin x, because the derivative of sin x is present in the numerator. So dt is equal to cos x dx, right? So I becomes now for cos x dx we can write dt. So we have dt here and divided by 4 minus t square, right? Now this can be written as dt and integral of 2 square minus t square, right? And now this integral can be written directly as sine inverse t over 2 plus c. Why? Because we know that the integral of 1 over square root of a square minus x square is equal to sine inverse x over a plus c. So for here the value of a is 2, and for x we have t. So this integral becomes sine inverse t by 2 plus c. And now we have sine inverse for t. We can write sine x, and this is 2 and plus c. So this is the integral of this function. Now let us take this problem. Here we have a definite integral from minus 1 to 1 x raised to 17 cos x raised to 4 dx. Now here we see that this is function, say f of x. This is x raised to 17 cos raised to 4x, and if we now replace x by minus x, we see that this is minus x raised to 17, this is cos minus x, cos of minus x raised to 4, and this is minus 1 raised to 17 is minus x raised to 17, and this is plus, because this is cos x raised to 4. Here cos of minus theta is equal to cos theta, so this term is positive. But here we have minus x raised to 17, which is a negative quantity, right? So we see that this is fx, x raised to 17 cos x raised to 4, so we have minus of fx. So we see that f of minus x is equal to minus of fx, so therefore fx is an odd function. This is an odd function, and we know that if a function is odd, then minus a to a f of x dx is equal to 0. So therefore the value of this function is 0. Now let us solve this problem. Here we have to integrate cos 6x times square root of 1 plus sine 6x. Again viewers, here we see that this function, it looks very difficult, but actually it is not difficult, because here we will make a very important substitution, and we will put t is equal to 1 plus sine 6x, right? So what is dt over dx? So dt over dx is 6 cos 6x, and dt over 6 is equal to cos 6x dx, right? Now here let us come to this integral. So this integral can be written as square root of 1 plus sine 6x, and cos 6x dx. Here we can write cos 6x dx, right? Now this is square root of t, because 1 plus sine 6x is t, and cos 6x dx is dt over 6, and this can be written as 1 over 6. 6 can be taken out of this integral, so we have t raised to half dt, and this is 1 by 6, t raised to half plus 1, 3 by 2. Here we have 3 by 2 plus c, and if we simplify it, we get 1 over 9. Here we have 1 over 9, t raised to 3 by 2 plus c, and if we resubstitute the value of t as 1 plus sine 6x, so here we have 1 plus sine 6x raised to 3 by 2 plus c. So this is the required integral of this function.